Good morning, students. Today we are taking a new topic, that is capacitor. See, it's a new topic, new term. And I can say that capacitor is a device, it is a component which can store charge and electrostatic energy within it. But how? What does it look like? How we are familiar with this? Where we use it? Many questions arises in our mind. So see, you can see here I have taken one box of a capacitor where the diagram has been drawn of capacitor. So this is a capacitor. This has been a capacitor. Another name for it is condenser, that was used in earlier time. And you can see here its rating is given 2.5 microfarad. Other specifications are also given. This is basically a capacitor. So if I will open it, I will show you that here this is a capacitor. See, this is a capacitor. What you observe, this is a cylindrical box-like structure with the two leads coming out to it. This is a capacitor. Basically, this capacitor, known as condenser also, this stores charge in it, and it comes in different ranges. Basically, it is used in micros and picos and nanos farads. We will understand this concept, what unit I am mentioning here. Basically, this capacitor, like you are familiar with the topic, that is resistor, you have done in class 10. Capacitor is a new term we will use here. So this capacitor is used in fans, motors, chargers, at many more places. Here there are two terminals. This is one terminal, this is another terminal. Before coming to the description of this capacitor, I will say it is consisting of two conductors, two conducting plates, separated by some medium, insulating medium in between. That can be air, paper, any other medium, mica. Different kinds of dielectric medium is placed in between. They come under different categories: paper capacitor, mica capacitor. I don't have any, just those small components at home. You can just see it in the lab by identifying the different types of capacitors. So this capacitor, so we have to start the term capacitor. Capacitor, to understand the concept of capacitor, we have to again coming to the conductor, because it is obtained simply from the conductor. So here we are taking one particular term, electrical capacitance of conductor. See, when you are talking about resistor, what you measure, it's resistance. When you're talking about capacitor, what you measure, it's capacitance. So how to measure, that will be a different concept. First of all, we will understand it. Electrical capacitance of conductor. It is basically its ability to hold electric charge. Ability to hold some charge. Like this is any conductor. We are giving some charge to it. Any amount of charge. So there can be different shape conductors can be there. Simply I am taking any conductor. Now can we go on adding, pouring some charge over it? Or is there some limitation? There will be some limitations. We can, like for it you can understand, suppose there you have a bucket. Like within this bucket, what amount of water you can add? Up to its capacity, up to its brim. But if extra water will be coming in it, what will happen? It may flow down. It may fall down. Likewise, when extra charge will be given to the conductor, it will not remain on the surface, it may leak. So here, basically, when the charge is given to a conductor, that will be stored over it. But extra charge may leak through the surface. Now, So when some conductor is given some charge, it acquires certain potential. As we know, potential is proportional to charge. More will be the charge given to it, more will be its potential. So charge on the conductor increases, its potential also increases. When we increase charge, potential also increases. We basically know that V is proportional to Q. But here, we will just take it in the reverse order, that charge is proportional to potential. Potential increases, charge increases. Potential decreases, charge decreases. Although charge increases or decreases change the potential. Now, when you are removing this proportionality sign, then you are getting a term C, this constant C, where this C, this is taken as capacitance. This is taken as capacitance of conductor. This is constant. Here what we are measuring. So C is given by Q upon V, charge per unit potential. So capacitance of a conductor is defined as the ratio of charge given to the conductor to the rise in its potential. Whatever charge is given, it will raise its potential. So this ratio, Q upon V, this is taken as capacitance. This capacitance, now on what factor it depends? Basically, it depends upon the nature of surrounding medium around the conductor. What is the surrounding medium? What is the shape and size of the conductor? And presence of other conductor in its neighborhood. If some other conductor is present in its neighborhood, then you will say that the capacitance may vary. We will discuss these points one by one. So here, as we know that Q equal to CV, from this, what we conclude? See, from each relation, some graphical representation also exists. As when we are giving charge, what will happen? Its potential will change. As V is proportional to charge, so the graph will be a straight line. From this graph, if we will find its slope, the slope will be V upon Q. But this is reciprocal of capacitance. So slope of this graph, it will give you reciprocal of capacitance. Now, this capacitance is independent of nature of material of conductor and the amount of charge existing on the conductor. As you can say that capacitance is given by Q upon C, so it should depend upon Q. No, it is not depending upon nature of conductor itself and the charge present on it, but rather it is depending upon nature of surrounding medium, shape and size of conductor, and presence of other current conductors in its neighborhood. So these points will be we will discuss one by one. Now, as we have introduced capacitor, so next point is to discuss SI unit of capacitance. SI unit of capacitance, as capacitance is having unit farad, named after microfarad. Now, capacity of conductor is said to be 1 farad. 1 farad, as C is equal to Q upon V. So if capacitance is 1 farad, it will be equal to. So how can we define it? Capacity of conductor is said to be 1 farad if some extra charge, some charge of 1 coulomb is given to increase its potential by 1 volt. So this is SI unit of capacitance. Now, next topic we are taking to find capacitance of an insulated spherical capacitor. So, we are considering an isolated spherical conductor of radius r and center O. Let Q, capital Q, with a charge uniformly distributed over entire surface. Now, as the charge is present over the surface, so potential at any point, any of the point on the surface, Q is a charge present, so potential is given by KQ by R, because we are taking a point on the surface distant R from the center. So potential will be 1 by 4 pi epsilon naught Q upon R. This statement is known to you as potential relation is KQ by R. Here we have to find capacitance of an isolated spherical capacitor. So basically, as capacitance is Q upon V. So from this first relation, if you will find the ratio of Q upon V, so it will come in the numerator. What you will get? 4 pi epsilon naught R. So it means capacitance of an isolated spherical capacitor is given by this. 4 pi epsilon naught, that is a constant. So C is proportional to R. More will be the radius, more will be the capacitance, because it is directly proportional. So if we take, let me take capacitance to be 1 farad. That we are taking capacitance to be 1 farad. So its capacitance is given by 4 pi epsilon naught R. So what will be the radius in that particular case? C by 4 pi epsilon naught. As capacitance is 1 farad, the value of 1 by 4 pi epsilon naught, that is multiplied by 9 into 10 raised to the power 9. So, or this will come out to be 9 into 10 raised to the power 9 meter. Such a large value. It means to hold the capacity of 1 farad, the radius of this sphere will be such a large, or you can take it as 9 into 10 raised to the power 6 kilometer. So such kind of capacitance is very big, very large. So practically it is not possible to have the capacitance of 1 farad. This capacitance is taken to be 1 farad is very bigger unit of capacitance. So practical unit we are taking in microfarad, millifarad, picofarad, nanofarad. Those values we are using. Even the capacitor which we are using in the fans, that is having values that is in microfarad, 2.5 microfarad. Why that is used there? Because if the fan is not working, it means its condenser is weak. That needs to be replaced. So smaller values of capacitance is required. So such a large amount of capacitance, that is 1 by 1 farad, cannot exist. Now on the basis of the same formula, Sc is equal to 4 pi epsilon naught R. If you want to find the capacity of Earth, so basically what is the radius of Earth? We know it is 6.4 10 raised to the power 6 meter. So here putting the value of these 9, this is your, you can take it as 4 pi epsilon naught Re. Now 4 pi epsilon naught, it is multiplied, so its value 1 by 4 pi epsilon naught is 9 into 10 raised to the power 9. So here Re is this one, and the value of 1 by 4 pi epsilon naught, this will come in the denominator. When you will solve it, it will come out to be 711 microfarad. You can check its value. See, Earth itself has such a large radius. When radius is so large, corresponding to it, capacity of Earth is in microfarad. So capacitance is always, when we are using here, that will be in nano, pico and microfarad. So basically here we have produced a formula of capacitance of spherical capacitor. That formula is 4 pi epsilon naught R. This is a result that will be used in numericals too. So now on the basis of the concept of capacitance we have done, then we will introduce one numerical. This numerical, see in this numerical, 27 spherical drops of radius 3 millimeter each and carrying charge of 10 raised to the power minus 12 coulomb are combined to form a big drop. Find capacitance and potential of big drop. See, such kind of question we have done in calculating the potential also, but here we have to find capacitance. So how to do it? So in this numerical, what is given? Number of drops, that is 27. Each is having radius 3 into 10 raised to the power minus 3 meter, and it is carrying a charge of 10 raised to the power minus 12 coulomb. Now these drops, 27 drops, combine to form big drops. So when these are combining, which factor will remain same? Volume. So volume of bigger drop will be 27 times volume of small drop. So let me take capital R is a radius of big drop, small r is a radius of small drop. So volume, that is spherical in shape, so its volume is 4 by 3 pi r cube. then 27 into this, we have taken capital R, sorry. Now here it will be 27 4 by 3 pi r cube. Now 4 by 3 pi will cancel out. R cube is equal to 27 r cube. So from here r will be equal to 3r. Directly we can find, taking cube root on both the sides. Now radius is given to be 3 into 10 raised to the power minus 3 meter. So it will be 9 into 10 raised to the power minus 3 meter. So from the concept of volume, that radius comes out to be this one. Now, as volume we have to calculate. So first of all, let me take, as we have to find from this volume, we have calculated the radius. We have to find capacitance here. So for capacitance, what we require here, we have to find capacitance and potential. So for that, Q equal to C into V. From this result, what we require, first of all, let me take the charge of big drop as 27 times charge on small drop. So it will be 27 into 10 raised to the power minus 12 coulomb. Now charge we have taken, we have to find its potential and capacitance. So capacitance of bigger drop. Now we will use the formula. This is equal to 4 pi epsilon naught r. Because it is spherical in shape, so for the spherical conductor, the capacitance is given by 4 pi epsilon naught r. So here radius r is given by this value. Now here it will be 9 into 10 raised to the power minus 3 divided by 9 into 10 raised to the power 9, 1 by 4 pi epsilon naught. So it will come out to be 10 raised to the power minus 12 farad. You can take it as 1 picofarad or leave at such. So from here you have calculated the value of capacitance. Charge is there. So as per the statement, now what is required? Potential. So potential will be given by charge per unit capacitance. So here it will be 27 10 raised to the power minus 12 charge, and capacitance is 10 raised to the power minus 12. So it will come out to be 27 volt. So see, as we have to start here, 27 drops are combining. So correspondingly, volume of bigger drop is 27 times volume of small drop. From there you have calculated the value of radius. Now, as we have to calculate capacitance and potential. So for capacitance, we know 4 pi epsilon naught r. Radius is known, you can easily calculate capacitance. But to calculate potential, you also require charge. As capacitance we have calculated, so charge will be given by 27Q. So this way you have solved it. Now taking one conceptual problem, two copper spheres of same radii are charged to same potential. Which has more charge? See, we have two copper spheres having same radii and charged to same potential. So, as we know, capacitance is 4 pi epsilon naught r. So, C is proportional to R and Q equal to CV. So, R is same. It means when R same, capacitance will be same. And V, it is given to be same. So C same, V same. So charge will also remain to be same. Irrespective of whether if it has been given that these are hollow spheres have been given or identical spheres have been given, but main concept is radii is same and charge to same potential. So charge will also remain to be same. Now, there is another conceptual problem, that sketch a graph to show how charge Q given to a capacitor of capacity C varies with potential. So here potential and charge graph you have to plot, and for it basically as we know that Q equal to CV. So C is proportionality constant, so the graph should be a straight line. We have already drawn it, but I will say the graph is some like this. What is the significance of it? Why the graph is following this curve? Actually, what happened, as we have already explained, that when some charge is given to a conductor, certain amount of charge will raise its potential, directly proportional. But when extra charge will be given to it, that charge may leak. That charge may leak to the surrounding. When the charge is leaking, so in that particular case, that will not contributing to potential. So at this point, when the potential remains to be constant, after that it will come out to be constant. Rather, you can take it as exactly that this will be like this, and after that it is constant. So here potential is increasing with the rise of charge, but when extra charge is given, after that there will be no increase in its potential. It will remain to be same. Now, one more conceptual problem. As what is given here, one graph has been given between potential and charge for two different capacitors, B and A. Now, out of these two, which will having higher capacitance? You have to judge out of these two which will have higher capacitance. As we know, Q equal to CV and C is Q upon V. If you will take slope, then you will find that V upon Q, it is giving you reciprocal of capacitance. So one method can be that for a given charge, which will have more potential, B, which will have more potential. So potential of B is greater than potential of A, and potential is inversely proportional to C. You can say that capacitance of A will be greater than that of B. Directly from this relation you can say this is complete. Or in another way you can say that the slope of A is less and slope of B is more. Slope of B is more. It means here 1 by C, reciprocal of capacitance will be more for B. That means capacitance of A will be more. So either you use the concept of slopes or directly by taking this result that for a given charge, potential is inversely proportional to capacitance. So from this graph, you can easily find that which will have more capacitance. Now next topic which we have to start, that is capacitor and its principle. So basically capacitor, it is an arrangement to store charge and electrical energy in the small space. Let a capacitor is consisting of one conductor A on this insulating stand, and let by certain means some charge is given to it. Let some charge, positive charge is given to it. Now the charge is given to it by some other source so that its potential become maximum, so that after that no further extra charge can be given to it, otherwise the charge will leak through it. So up to maximum value charge is given to it. Let another insulated metal plate B, held near this plate A, separated by a certain distance. So what will happen, as it is brought closer to it, here the medium air is taken in between. Medium can be some another also, insulated medium. So what will happen, by induction, the inner phase of plate B, it will acquire negative charge. How? By induction. And the farther end of B will acquire positive charge. Why? Because electrons will experience a force of attraction. By induction, the electrons will be accumulated on one side and positive charge on the other side. Actually, the plate is like this. We are simply showing it by a line. So this will accumulation of negative charge on this side and positive charge on this side. Actually, the concept is this one. So by induction, a negative charge is induced on the inner end of B, and equal positive charge develop on the farther end of B. So what will happen? The induced negative charge of B, due to attraction, it will tend to decrease the potential of A. Due to attraction, there will be some charge movement. So, and hence you can say this negative charge will tend to decrease the potential of A. So, when this potential tend to decrease, where is farer end of B? Where positive charge. But the purpose of it, that the like charge will be there, it will tend to increase the potential of A. It means, what does it simply mean? That the negative charge will tend to neutralize, whereas positive charge will not make any change in the charge of A. So actually what happened, that induced negative charge is close to A. Therefore, the overall potential of A get reduced. This positive charge is away, it will have least effect. So negative charge will tend to decrease the potential of A. So in that particular case, now its capacity, then it will be, it means like this, if some bucket, in one bucket some water is taken out from a mug, then another one mug of water can be added to it. We can understand it way that one bucket of water is there and it is completely filled, but by certain means, if mug of water has been taken out, then another mug of water can be added to it. So likewise, more charge can be given by certain source to it, again to raise its potential to maximum, same maximum value up to which initially it was given. Initially it was charged to maximum value, but due to the induced negative charge, its potential is reduced. Now more charge can be given to it so that it will come again to its maximum potential. So now what will be there with the positive charge? Actually what we will do, we will connect it to ground. So purpose of grounding will be that to have no effect of this positive charge on this potential of A. So it is grounded. So what happened? This positive charge will move to ground. But actually what happened? Electrons from the ground come to neutralize this positive charge. Actually the movement particle is electron only. Positive charge cannot move. That is simply a vacancy of electron. So electron from the ground will neutralize this positive charge, and hence what is the main concluding point of this capacitor and its principle? That capacitance of an insulating conductor is increased by bringing this uncharged grounded conductor near it. Actually what we have taken, initially A was charged conductor, right, and B was uncharged conductor. So when, if this was not present, this was charged to maximum value, but when it is present, so by induction then it may be decreasing or increasing the potential of it. So due to its presence, the potential of this will be changed, the charge of this will be changed. So when this is grounded, what happened? The negative charge induced will tend to decrease the potential of A, more charge can be given to it. It means what we are getting, that capacity to get more charge of plate A will be increased by bringing uncharged grounded conductor near it. So that's why we say that capacitance of this insulated conductor is increased by bringing uncharged, earthed or grounded conductor near it. This principle is important. Sometimes it can be asked to explain the working principle of capacitor. So you have to explain all this concept. See, all this is theoretical concept, nothing to do with the numerical part or mathematical part of it. You have to explain all the points which I have discussed with you.